Sunspots. They've fascinated sky gazers through the ages. Now, state-of-the-art telescopes combined with the muscle of a supercomputer called Bluefire are allowing scientists to accurately model these mysterious structures and unlock their secrets.
Sunspots are the manifestation of very strong magnetic fields at the solar surface. They are cooler than their surroundings. This is why we see them as dark spots on an otherwise much brighter solar disk.
Michael Knölker and Matthias Rempel are solar scientists working at the High Altitude Observatory at the National Center for Atmospheric Research, known as NCAR, in Boulder, Colorado, funded by the National Science Foundation.
Studying sunspots is extremely important for understanding how stars like the Sun produce magnetic field, which is still one of the big outstanding unanswered questions in stellar astrophysics.
Scientists know sunspot activity waxes and wanes on an 11-year cycle, and it is often accompanied by solar flares. Sunspots are also associated with coronal mass ejections, or solar storms, in which a massive cloud of charged particles erupts from the Sun and washes out across the solar system.
In a slow release process, slow at the beginning, a magnetic bubble pops off out of the solar atmosphere, is then accelerated very quickly and then drifts into interplanetary space.
Geomagnetic storms are triggered when those charged particles hit the Earth's magnetic field, which envelops the planet like a cocoon, extending out into space. That extra energy jolt to the system can do some serious damage.
With that disturbance come disruptions of shortwave radio communications, radiation exposure for astronauts who are in orbit, and other consequences that in modern society we are very concerned about.
The power grid is also particularly vulnerable, as more juice zapping through the atmosphere can overload transformers. Maybe the only good thing about a geomagnetic storm is that it really lights up the auroras, putting on a spectacular light show. This photo was taken by a scientist at NCAR a few years ago in the aftermath of a solar storm. The northern lights are only rarely seen as far south as Colorado.
That is the beautiful side of a geomagnetic storm, and it has drawn the attention of humans since the beginning of human consciousness, we believe.
A flood of new data from solar telescopes like the orbiting Hinode is helping scientists perfect their sunspot models, including what's going on inside the Sun.
When we do a numerical simulation, we want to make the connection between what we can observe at the surface and the motions of ionized gas in the layers beneath, several thousands of kilometers beneath the surface.
Better understanding of sunspots also will help scientists sort out the role solar cycles play in climate change on Earth. Knölker believes what we are observing in terms of climate change over the past 30 years should clearly be chalked up to human activity. But he says there's no doubt that the Sun is also playing a role over time.
There cannot be any doubt that this research area has an obligation to humanity to pin down to what extent the solar activity variations play a role in climate.
And ultimately, a deeper grasp of the working of our own star will help us as we look beyond our solar system for Earth-like planets elsewhere in the cosmos. Those as yet unfound pale blue dots are orbiting their own suns. The more we know about our own solar system, the better prepared we'll be to understand others. For Science Nation, I'm Bruce Burkhardt.